It is Thursday, February 18th, and it is time to check our bell work. So your bell work should be all the way done, and you are just here to check to make sure your answers are correct. And if they're not, make sure you fix them and make those corrections so you can learn something new. Okay, the first set, I just ask you to solve, and I hope you notice there is addition, subtraction, and multiplication, so pay attention to the signs. For number 1, 4/5 plus 1/10 is not 5/15. You can't just add them. Remember, we need the pieces to be the same size when you're adding fractions. So the first thing I would ask myself is there something I can multiply 5 by to get 10? Is there something you can multiply the lower denominator by to get the higher? Yes. So I would have multiplied this first fraction by 2/2 to get 8/10 plus 1/10, which is 9/10. So 9/10 is what you should have. If you changed this to 50ths, your answer will simplify down to 9/10. For number 2, I have 1 and 11/12 minus 3/4. And this is subtraction. That means I need to have the same piece sizes. That means my denominator needs to be the same. So when I see a 12 and a 4, I think, hey, 4 times 3 is 12. So I'm going to change this one by multiplying it by 3/3. So now I have 1 and 11/12 minus 3 times 3 is 9/12. And this one's kind of nice because you can take 9 away from 11, right? So 11 minus 9 is 2. My denominator doesn't change, and 1 minus, there isn't a whole number, is 1. Now that 2/12 can also get fixed up because they're both even, and remember, if they're both even, that means they're automatically divisible by 2. So your final answer should be 1, and 2 divided by 2 is 1, and 12 divided by 2 is 6. So 1 and 1/6 should be your final answer for number 2. All right, now we're into some multiplication here. And first off, I see a whole number there, so I'm going to rewrite it with a 1 underneath it. And for mixed numbers, remember, we need to change those to improper when we're multiplying. 5 times 2 is 10, plus 1 is 11/5. Now, you could be thinking, I don't want to do 15 times 11. Well, you don't have to, because 15 and 5 are diagonal from one another, and you can cross-simplify that. 5 goes into both of those. 5 goes into 5 once, 5 goes into 15 3 times. So you're left with 3 times 11, which is 33, and 1 times 1, which is 1. And 33 divided by 1 is 33. And please remember that if you had 1 over 33, it's not 33. 1 divided by 33 is not 33. It means you only have 1 out of 33. Okay, this is like saying 33 divided by 1. Okay, number 4, straight up multiplication. I see the same digits directly across from one another, but not diagonal. So I can't just cross out those 3's and put 1's. But here, if you look 3 and 9, you can. So I can go ahead and say 3 goes into 3 once, 3 goes into 9 3 times, 3 goes into 3 once, 3 goes into 9 3 times. Or you could have just said, hey, 3 9ths equals 1/3 and simplified them both to start. But no matter what you do, 1 times 1 is 1, 3 times 3 is 9. You get 1/9 for your final answer. Even if you multiplied across, like regular multiplication, you'd have 27 over 81, and you could simplify that, okay? Oh, sorry, you wouldn't have 20, you'd have 9. What am I doing? 9 over 81. And if you had 9 over 81, 9 goes into both of those. Okay, number 5. I love it when I see the same digit diagonal from one another because I know that 7 goes into both of those one time. And you can actually simplify this 6 and 10 further. 2 goes into both of those. 2 goes into 6 3 times, and 2 goes into 10 5 times. So we end up with 1 times 3 is 3, and 5 times 1 is 5, and 3/5 is your final answer. If you had 42/70ths, you're on the right track, but that can be simplified. Okay, number 6, 1 and 1/9 times 1 and 1/9. I have to change these into improper fractions before I can multiply. 9 times 1 is 9, plus 1 is 10/9, and another 10/9, and I can't cross-simplify anything. So 10 times 10 is 100. 9 times 9 is 81. 81 will go into 100 one time, and 81 plus 19 is 100 out of 81. So you should have 1 and 19 out of 81. Okay, this is what we started to learn about yesterday. It says, write the multiplication equation equivalent to each division equation. Okay, so we saw yesterday that when you took 8 divided by 9, that was actually the same as 8 times 1/9. Because remember, we took like the 8 waffles and we cut them each up into 9 pieces. And if each person got 1 out of 9 pieces, that's where that came in. So if you have 1/9 8 times, that means you have 8/9. So this really, like 8 over 9, that's 8 divided by 9. Fractions are just little tiny division problems. So if you have 3 divided by 8, picture that you'd take the 3 waffles and we'd cut them up into 8 pieces and each person would get 1/8. So that's the same as 3 times 1/8. And if you have 1/8 3 times, 1/8, 1/8, 1/8, that means you have 3/8. So 3 divided by 8 is the same as 3/8. Number 9 asks, how can you divide 2 cookies between 3 people? Okay, so I'm gonna draw my 2 cookies. And if I want to divide those between 3 people, that means I'm going to take each cookie and cut it up into 3 pieces, right? And then each person would get 1 piece of the cookie. So this is how I would divide it up. Person number 1 would get those 2 pieces. Person number 2 would get that. Person number 3 would get that. So how can you divide 2 cookies between 2 cookies between 3 people? 2 divided by 3. You can say, well, each person gets 2 times 1/3, which is 2 thirds. And we'll have a whole big discussion about inverses and all kinds of stuff, but this is a nice way to start to understand how these inverses work when you're using your opposite operations. So 3 divided by 8 is the same as 3 times 1/8. And same for 8 divided by 9, 8 times 1/9. 2 divided by 3, 2 times 1/3. This will get to be a very important topic, especially today with what we're gonna learn. Thank you so much for checking your work.